This is 7.3. Looking at this function h, the question wants to know, where does this function not exist? And it asks that by saying, what are the excluded values? So the excluded values are any numbers that we plug in and they break the function. And there are only really three ways to break a function. One is to divide by 0. One is to square root a negative. And then one is to try to plug a negative number inside a logarithm. Okay, so those are the three things you need to look out for when you're dealing with domains. And the only one that's going to apply in this module is divide by 0. So I need to factor the denominator, and this will be x plus 8 and x minus 7. And the top is x plus 5, but that's not really going to factor into this problem. So what numbers will break the denominator? Well, if I plug in x equals negative 8, then this becomes 0. And 0 times whatever happens over there is 0. And I get x plus 5 over 0, which is, it's not x plus 5, it's actually negative 8 plus 5 over 0. I just plugged in negative 8. So if I stick a negative 8 in there and there and there, then I end up with this, which is undefined. And the reason it's undefined is because it's infinity. And you'll see that here in just a little bit. Because it's, so this is 0 times negative 15, which is 0. So the 0 breaks the bottom, or the negative 8 breaks the bottom. Okay, so x is not allowed to be negative 8. Similarly, x is not allowed to be 7, because then I would get 7 plus 5 over 15 times 0, and the bottom is 0 once again. So anytime you have a factor in the denominator, the root associated with that factor is what we call an excluded value. So let's do another one of those. Negative 8 and 7 are the answers, yeah. Okay, so x plus 6 and x plus 3 on the bottom. We could factor the top, and that would be x minus 4 and x plus 2. But when we're looking for excluded values, the numerator doesn't matter. So in this case, x cannot be, or actually I guess they want to say x equals negative 6 and negative 3. Those are the excluded values. Those are the numbers that if you plug in, you get undefined. Everybody understand that? What if it had x squared minus 6x? How do we factor that? We pull out an x, and what would the excluded values be? Well, this one is 6. What about that one? 0. So x, the excluded values are x equals 6 and x equals 0. All right. Okay. What is the excluded value here? There's only one of them, 5. So we know that x cannot be 5. What happens at 5? Well, we have this really weird structure called a vertical asymptote. That's how you spell asymptote. It's Greek. Go figure. Okay. So x cannot be 5 because we have an imaginary vertical line at 5. And the graph is either going to look like this, or it's going to look like this. So what happens as we get closer and closer to 5? Well, the number is going to get bigger and bigger and bigger. And it turns out in this case, the graph looks like this. Nope, I'm wrong. And you'll understand this later. This is not so important today. So let's start plugging in numbers that get closer and closer to 5 and see what happens. So my function is -9 divided by, and let's do 2 minus 5. We get 3. Now let's plug in 2.5. Let's do it this way. -5 plus 2.3. Okay, let's plug in something bigger. 2.8. So that got a little bit bigger. Let's say 3.8. Let's plug in 4.8, 4.9. Oops. 4.99. No, that's not what I wanted. 4.999. You see what's happening? The closer I get to 5, the larger that y value becomes. And if I actually try to plug in 5, so -9 divided by -5 plus 5, it's going to give me error. So as x gets closer and closer to 5, the y value gets higher and higher and higher. Can we ever actually hit the 5 on the x-axis? No, because we're dividing by 0, and you're essentially turning it into infinity. You can see that this line is flying off to infinity. Now, if I were to come from the other direction, I'm going to approach negative infinity. So if I were to pull up this, and I were to say 6, now I'm at -9. So if I do 5.5, now I'm at -18, 5.9, -10, 5. Oh, that's not what I wanted. I want to go close to 0, huh? 5.1, -90, 5.01. Now I'm headed off to negative infinity. So that line is called a vertical asymptote. And if you have a factor in the denominator, you have a vertical asymptote. If, this is really important, it's not going to apply today, but it will apply next time, if that factor is not also in the numerator. Okay, so make sure that you understand that. That's really important. If I had -9 times x minus 5 over x minus 5, if those cancel, it is not a vertical asymptote, it's something else. But in this case, we don't have any factors up there. So if this does not cancel, then we get a vertical asymptote. Can you remember that? And again, that's not going to apply today. What about horizontal asymptotes? So a lot of these functions have a horizontal line that also is an asymptote. So this is my graph. How do I determine what the vertical asymptote is? Okay. If the degree of the bottom is larger than the degree of the top, then your horizontal asymptote is at y equals 0. Okay, so let's say we had 4x squared minus 6x plus 2 over 18x to the third minus 6x squared plus 2x minus 1. All right, if you look at this, what happens when I plug in huge numbers. When I plug in huge numbers, so 4 times a huge number squared minus 6 times a huge number plus 2. How much of an effect is that 2 going to have on my answer? If x is really big. Not much at all. Let's try one and see. So let's do 4 times 10,000 squared minus 6 times 10,000. Okay. If I add 2 to that, does that 2 really matter? So we're looking at hundreds, thousands. So $399 million. If you have $399 million, how much value is there really in that $2? It's not very important. Would you agree? So when x is really big, we can sort of ignore this. Does the 2 have an effect? Yes. But that 2 is so small compared to the 399 million. We're just going to pretend it's not there. Okay? Well, look at the bottom. When this is really, really big, what effect is the negative 1 going to have? Very little. In fact, how big is 2x compared to 18x to the third? Well, let's look. So 18 times 10,000 to the third. Okay, that's a really big number, right? Well, what about 2 times 10,000? It's tiny, right? So when x is really, really large, yes, this does have an effect, but the effect of the 2x is very tiny compared to the 18x to the third. And we can use that same logic to say this is insignificant compared to that. And this is insignificant compared to that. And this is insignificant compared to that. So when we're looking at what happens on the x-axis on the far, far right, all that really matters are these. Oh, they good looking? Oh, I hope it was worth it. So if I take 4x squared over 18x to the third, that's going to simplify down to 2 over 9x. Would you agree? So this graph here on the far, far right is going to look a lot like that. Well, what happens when I plug a really big number into 2 over 9 to the x? So let's type that in. So 2 divided by 9 raised to 10,000. Oh, that's not what I wanted. So 2 divided by 9 times 10,000. What is that number? Essentially, it's tiny. Tiny, 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 right? 0.0002. So this graph, if I go all the way out, sorry, that's not what I wanted to do. I think I need to close this. No, we're going to have to go back in. I broke it. Sorry. Okay. So if I go way over here to 10,000, how high is the graph? 0.00002, right? It's essentially 0. So when I plug large numbers into that graph, the graph is going to get closer and closer to 0. How do I tell? Well, it comes down to this. If the bottom has a higher exponent than the top, that means we're going to get bigger numbers in the bottom, right? If there are more x's, not the number of x's, but the exponent. So if this number is smaller than that number, then my HA is going to be 0. Why? When you take a small number and you divide it by a big number, you get a small number. Okay? So if the bottom is stronger than the top, your HA is 0 every time. Okay? What if we had this? What's going to happen on the edges? Well, when we plug in big numbers, this is insignificant. So is this, and so is this, and so is this. Okay? So let's look at 4x squared over 6x squared. What happens when I plug a huge number in there? What's going to happen? What is 4 times a huge number squared divided by 6 times the same huge number squared? Well, a huge number squared divided by a huge number squared cancels, and 4 over 6 just becomes 2/3. So, if the degree of the bottom is equal to the degree of the top, divide the coefficients, and that is your HA. What does that mean? Well, whatever this graph looks like, so we could have an HA there, or a VA there, and a VA there, vertical asymptotes. But at 2/3, we have this magic line, and the graph on the edges is going to get closer and closer to those lines. So it could look something like this. Now, notice, I punched a hole in the HA. That's okay. Sometimes that happens. You can never, ever, ever intersect a vertical asymptote. But the horizontal asymptotes only apply on the edges. In fact, we could have a graph that looks like this. You can actually come down and go through and then back up. So if the bottom and the top have the same degree, the HA is simply the ratio of the leading coefficients. 4 over 6, which is 2/3. What if the top is stronger than the bottom? Then you don't have an HA, you have a slanted asymptote. So it's possible to have a graph where you have a slanted asymptote. So it could look something like that. Okay, we'll get to those later. So what you need to remember today is, if the bottom has a stronger exponent than the top, the HA is 0. If the bottom and the top have the same degree, then the HA is whatever the ratio of those leading coefficients is. All right, so let's do another one. So this is 7 over -3 times x plus 1. Do I have a vertical asymptote? Yes, at -1. What about my horizontal asymptote? Well, the exponent on the bottom is a 1, and the exponent on the top is a 0. If the bottom is stronger than the top, your HA is at 0. Okay? What if I had 2x minus 6 over, let's say 12x minus 6 over 10x plus 15. So the top becomes 6 times 2x minus 1, and the bottom becomes 5 times 2x plus 3. So I have a vertical asymptote at, what is the root associated with 2x plus 3? Set that equal to 0. Subtract 3, divide by 2. So negative 1.5. Okay. And then which is bigger, the bottom or the top? They have the same degree, right? They're both first power. So I divide these. 12 divided by 10 is 6/5. That is my HA. Can you remember that? All right. Next one. Okay. So we're starting with 1 over x squared. If I multiply this by something, I am going to affect its height. If I multiply it by 2, it becomes twice as tall. If I multiply it by 10, it becomes 10 times as tall. If I multiply it by 1/2, it becomes half as tall. Okay? And then if I add or subtract to this, that's just going to move it up or down, depending on whether it's positive or negative. Okay? So, if I take 1 over x squared, what do I need to do to it to get that? Well, I'm timesing the top by 3, and I'm subtracting 2. Okay? I think I have to do this for my computer. So I need to stretch this. I need to stretch it from 1 to 3. And I need to shift it down 1, 2. Okay, here. Oh. If I add and subtract to the x, it's going to go in the opposite direction. So x minus 1 means I'm going to move it to the right 1. So from here to here, and then down 5. Oh. 1, 2, 3, 4, 5. Okay. All right, negative out front is going to flip it upside down. So I need to flip it upside down. X plus 4 means I change the x by moving left 4. Excuse me. Okay. All right, let's do some more. All right, I'm timesing the top by 3. Multiplying the top by 3 means we make it 3 times taller. And x minus 2 means we move it to the right 2. One more. So this is left 2 and down 4 right there. Okay. All right, so graph the function. Well, I know that I have an asymptote at 4. So I'm going to draw a vertical line at 4. Also, the bottom has a stronger x than the top. So I have a horizontal asymptote at 0. Okay? Now, I have to decide, is it going to be this graph or this graph? Right? Those asymptotes always have opposite directions. If one side is up, then one side is down. Okay? Now, there is an exception to that, but we're not going to worry about it today. So, I just need some point. If I learn that that is one of the points, then I can draw the graph like this. If I learn that this is one of the points, then I can draw the graph like that. Okay? So normally we would only pick one point on either side, and then that would tell us where to graph it. But Alex needs a little bit more information, so plot 2 points on each side of the graph. So let's plug in 0. What happens when x equals 0? Well, that is 4 over negative 4, which is negative 1. So 0, negative 1 is one of the points. Okay. Well, what happens when x equals 1? We could do that. So 4 over 1 minus 4 is 4 over 3, negative 3. And then you would need to graph that using this. But let's just pick a point that's going to make the graph easy. Can you pick an x value over here that's going to create a nice number? What would a good value be? 4 we can't do. So 3 would work. So let's plug in 3. You could graph 1 comma 4 over 3 if you want. That will totally work. But then you'd have to use this button. So if we plug in 3, 4 over 3 minus 4 is 4 over negative 1, which is just negative 4. So 3, negative 4, like that. Okay? What about this side? Are there any numbers you could plug in that would make for easy answers? Seven is a bad idea. 4 divided by 7 minus 4 would be 4 over 3. 8 would work. So 4 over 8 minus 4 is just 4 over 4, which is 1. So 8 comma 1. There it is. What else would be a nice number? 5 would be nice. 4 over 5 minus 4 would be 4 over 1. So we could do 5, 4. We could also do 6. 4 over 6 minus 4 is 4 over 2, which is 2. And we could do 6, 2. And once you have those selected, then choose this, and it will draw the curve for you. Okay, let's do another one. All right, so negative 2 over, I'm going to pull out a negative 1, and I get x plus 1. So my horizontal asymptote, my vertical asymptote is at negative 1. Negative 1 is the number that makes this 0. So I draw a vertical line at 0. The bottom has a stronger x than the top, so my HA is at 0. Okay. What numbers are going to be nice to plug in? Zero will be nice, right? Negative 2 over 0 minus 1 is just negative 2. So 0, negative 2, there's 1 point. 1 would be nice. Negative 2 over negative 1 minus 1 is just negative 2 over negative 2, which is, oh, I got that backwards. Sorry, that should be plus 2. So 0, 2, and then 1, 1, 1. What negative numbers would be nice? Well, let's plug in negative 2. Negative 2 over the opposite of negative 2 minus 1. So that's negative 2 over 2 minus 1, which is negative 2. So negative 2 right there. Let's plug in x equals negative 3. Negative 2 over the opposite of negative 3 minus 1. So that's negative 2 over 3 minus 1, which is negative 2 over 2, which is just 1. So negative 3, negative 1. So negative 3, negative 1. And then you hit the graph button, and it will draw those for you. Okay, that's it for today. You can do this. Get to work.